I want to just take a minute here and show you another way that you could solve this problem. And one of the things that we'll start seeing is there might be more than one way to solve a problem, more than one roadmap that you can take, and both would be equally correct on an exam. So I'm going to kind of put another piece of paper here, and I'm going to keep some of this information kind of available, but in terms of, where we want to go, is figure out the molar mass. And again, the molar mass is equal to grams per mole, right? That's how we define molar mass. So if there was some way of finding out the mass of a gas that we have, and then dividing it by the number of moles that's equal to that mass of gas, then we could figure out the molecular weight. So this, again, is another way to solve the problem. This mass is given directly in the problem. Right, we knew that we had 0.582 grams of the gas. Now, if we used PV equals nRT, we could go ahead and we could solve for the number of moles. PV over RT is going to be equal to the number of moles, and we were given all of that information. We were given the pressure of the gas, again at 0.992 atmospheres. We were given the volume of the gas, which was equal to the volume of the flask, which is 0.213 liters. Again, R is our same 0.08206 liter atmosphere per mole Kelvin. And again, the temperature of that vaporized gas was the same as that of boiling water, which was 100 degrees C. 100 degrees C, which we need to convert to Kelvin. So sorry about that, which is going to be 373 Kelvin. So we can go ahead and solve for our number of moles, which is 6.896 times 10 to the minus third moles of gas. So that gas that weighs 0.582 grams, because of its pressure, volume, and temperature, means that there's that number of moles of gas. So now we have both pieces of information. So the molecular weight, again, of any gas is its mass. So 0.582 grams of this gas is equivalent to, in terms of pressure, volume, and temperature, 6.896 times 10 to the minus third moles of gas, and that ends up being 84.4 grams per mole. So within experimental error, 84.3 grams per mole, we get the same answer. And why I wanted to show you another way of going about this problem is always keep in mind thinking about, what do I want to get? I want to get molecular weight, which is grams per mole. If I have some way of knowing the mass of a certain amount of gas and the number of moles that weigh that mass, I can figure out molecular weight. Use that same thought process when it comes to thinking about, for example, density. Density is the mass of something and the volume that it's contained in. I think you guys do this in lab. If you have to figure out the density of an unknown metal, you weigh a little piece of metal and then use a water displacement technique to figure out the volume that that metal contains. If you take the mass of that metal and you divide by the volume, you'll get the density. Once you know the density of that unknown metal, you can compare it to standards and figure out what it is. The same is kind of true here, so always keep that in mind. If you don't know how to solve a problem, again, think about information that you know, where you want to go, and in this problem, knowing that we want grams per mole, we had information provided that allowed us to solve this problem in a different way.